up and they see each other and they wave and they give each other air high fives. All right? But 3 and 8 are equal to each other. But 8 is called an angle of what? Elevation. How would you classify angle 5? Depression. An angle of depression. An angle of depression. Here would be your person looking out over the horizon. And angle 5 requires them to look down at another point. Okay? Okay, now how is this applied? In the problems you're going to work tonight, you wouldn't actually be given the right triangle. You'll have to draw it. But what we need to do is draw a picture. Here's an example. You're going to go hiking up the side of Mount Kilimanjaro. Okay? Just making it up so the distances I give you are not going to be true, so please don't go look them up and say, huh, she was wrong. Okay. Now, obviously, a mountain is not a big triangle wedge floating around in space. Okay? Point A would represent the top of the mountain, where you are trying to get to. Point B would represent the base of the mountain, so where it hits the ground, where you're starting. Point C is not something that you would physically be able to see with your eyes when you're looking at the mountain. It is the distance from the top of the mountain straight down to the ground. So if you think about it, it would actually be like a bore or a hole bored through the center of the mountain. Okay? The distance from C to B is from that center to where you would be standing. So this would be from the base of the mountain to the center of the mountain. All right. Now, suppose I told you that when you are standing at the base of this mountain, looking up, there is an angle of elevation of, 46 degrees. Is angle A 46? Is angle C 46? Or is angle B 46? B. Angle of elevation. You are standing at the base of the mountain looking up. So angle B, in this case, would be your 46-degree angle. Suppose I told you that the altitude of the mountain was 2 miles above sea level. Have I just given you the length of AC, CB, or AB? AC. The altitude is the same thing as the height. What did I just say it was? 2 miles? Okay. And if I asked you, how far will you actually hike to get to the top of the mountain? Are you looking for AB or CB? AB. You are looking for the distance from A to B. How far will you actually hike? Okay, you can't hike to the center of the mountain. It's solid. You're going to hike up the side of the mountain. All right, now, when we get this, is it going to be exact? It's going to be an estimate, okay? Because obviously a mountain is not a perfect straight line. But we are going to estimate it. So here's your right triangle. Now you've got to decide, do I use SOHCA or TOA? So, very good. Because in reference to this angle, I have an opposite leg and hypotenuse, OH. So the sine of 46 is equal to the opposite over the hypotenuse. Would that be 2 over x or x over 2? 2 over x. Now how do you actually plug that in your calculator?
2 divided by 7.
Very good. Which means that you will actually hike a physical distance of around 2.8 miles, but it would probably be more because with the curves, that's going to add some distance, right? So you can say about 3 miles. 3 miles hiking up the side of the mountain. Hey. pretty tough. Never did it, but I bet it would be fun. Okay? We're going to draw a picture. We need to figure out what they're giving us. James and Parker, please pick your heads up. All right, in your book, there are a couple of examples. On page 705. And the picture's drawn for you, so don't look. I'm going to tell you. Okay, don't look. You have been hired to construct a bridge or to design a bridge to cross the Mississippi River. What is probably the most important thing you need to know? The length of the bridge, like how long the bridge needs to be, right? Okay. Well, what helps you determine how long a bridge is going to be? How wide the river is. Okay, so we're going to draw a picture. We have a river. And we need to know how wide it is, correct? Okay. Now in here it says that you place a stake on one side of the river and another stake on the other side of the river. Well, here are my two stakes. Then it says on one bank you step off 50 meters and put another stake. On one bank, let's choose the top one, okay? We're going to walk 50 meters in one direction and put another stake. So let's say we go this way. All right, here's another stake. What have I just created with those 3 points? A right triangle. Here's your 90-degree angle. Which one's 50? Is it the vertical line, the horizontal line, or the hypotenuse? The horizontal line is 50 because you stepped off 50 meters from one stake to the other. And you obviously cannot step it off across the river. Okay? Now, at this stake here that you've just stepped off, there is an angle of 82 degrees between these things. All right? So this is an 82-degree angle, which my picture is probably not to scale at all. And yours won't be either. But we want to get the gist of it and label. All right, now what did we say we were looking for? The width of the river. Because we want to build a bridge. Are we going to build a long bridge that will cover this hypotenuse? Or are we going to try to go just the shortest distance? Shortest distance. All right, so we are looking for this. Which means now we need to decide, do we use sine, cosine, or tangent? And what do we look at first to make that determination? The angle. You start with the angle, and you ask yourself, what do you know in reference to that angle? Opposite and adjacent. Which means we're going to use tangent. Tangent. In reference to this angle, I have the opposite leg and the adjacent leg. So that means I'm going to use the tangent function. The tangent of the angle is equal to opposite over adjacent. Would that be x over 50 or 50 over x? And now calculate that. We'll round to the whole number. Your bridge is going to be about 356 meters long. 356 meters long. Start with a picture. Draw it so that you can visualize it. Okay? The next example says that you are going snow skiing in Utah. And the ski run that you're about to ski has these characteristics about it.